Okay, so we're going to continue part 2 for Unit 4. So chemical analysis is another method that we use in predictive maintenance. So what we do here is we study the internal conditions, not the chemical, okay? We study the internal conditions of the equipment you are maintaining. Again, when we say equipment, that's your system and components. So why do we do it? Is we have to determine the cause of problems and also predict any impending failures, and also to decide on a course of actions in order for us to be able to save this equipment or maintain it. So in order for us to be able to study the internal condition, what we're looking at is a coolant and lubricants, because they're actually the lifeblood of your equipment. That's how they're surviving, because they don't have a nervous system and they're just a elemental structure. Ours is about chemical structure, so our structures are very different, but for equipment they need coolants and lubricants. Okay, and that's how we determine their internal condition. So when we study the internal condition, we look at the coolants and lubricants. So what are we looking at? It's inside of that coolants, we're looking for the contaminants. So, and we determine the level of deterioration depends on that concentration of that contaminants in the coolants or lubricants. Okay, that's how we determine the causes and abnormalities. Okay, so the technique that we use in chemical analysis, the first one is your spectrographic analysis. You call it SPECT or spectrography. What we do here, we use the radiation. Just radiation is nothing but just a light source. And then we're going to use it on a sample. So that's what we do in a spectrographic analysis. We determine the presence and quantity of various elements or compounds in the sample, okay, we're analyzing. So those samples usually come from your equipment. So spectroscopy, we use it for so many things. So here, industrial technology belongs to right here, materials technology. Of course, your research and development. So in this analysis, we analyze the lubricant. We use a radiation source and then detect and analyze the metal particles, okay? Again, the lubricants and the particles we're trying to detect, analyze are from your machine or equipment. So what we do here in this analysis is we always compare our sample with the standard. The standard, you will always get it from the normal or expected chemistry, okay, from their product. It's always come from your standard, and we call that the baseline spectra. So we come with your manual right in there, okay, with your product. And there are various lubricants in the market. So this analysis definitely detect the presence of numerous elements, and these elements are your airborne, pollutants, other contaminants, and each of which can point to a possible problem, okay? And what we're doing in our predictive maintenance is we're coming up with a solution for any kind of problem. So that's why we're studying everything that we need to know about that equipment, internal and external. So here is a partial list of elements found in lubricant and possible sources. So here, iron, you can find iron in cylinders, gears, pistons, crankshafts, bearings and housing, and rust. Chromium is your element from your periodic table. So if you remember your chemistry class from high school, okay. Also, if you take chemistry 1 and 2 here, at our school, then you're going to see chromium is in rings, bearings, and plating. Copper, bushing, bearings, washers, so and so. Okay, so various elements, and you can find these are your sources in your equipment. So excessive wear. So here we have metal particles from wear, and they're going to signal, these particles signal the abnormal equipment conditions. So what are the abnormal equipment conditions? You have improper alignment, you have components that are out of balance, you have inadequate clearances, intolerances, and so on. So again, your excessive wear, we're looking at the metal particles. Okay, showing all this. Second method is pH monitoring. So pH monitoring, we use it in a variety of applications: industry, chemical, and pharmaceutical processes, as well as in environmental processes like your wastewater treatment. You always have to take the pH of your wastewater plant all the time. Okay, there's a big maintenance right in there. So people who want to go into maintenance career, you definitely want to get a job right there. It's a boring job, but and also incredibly easy job to get lots of money. Yeah, maintaining only one system. Alright, so the pH of the solution is measured to study the level of acidity or alkalinity. So that's your base and that's your acid. So every time we study the pH, we're trying to determine, okay, the solution is acidic or basic. So pH, we call this alkaline anyway. So pH of the solution is nothing but just a number that you can get from here. You can get from your pH strips. You can also get from a sophisticated instrument studying pH. So that value is going to relate to the concentration of your hydrogen ions, not in the hydrogen molecule state, not H2, but at the stage of H+. So in a solution and the level of activity of these ions. So every time your molecule is broken into parts, molecule is also a system, and it's composed of different numbers of elements. We call them atoms. So for hydrogen, so regular hydrogen, you have 2 hydrogen atoms, and they are staying together in a bond. The bonds are not rigid. It's very kind of like a contact kind of bond, and we call that attraction as well. So how they're bonding is they're bonding with ions, plus and minus. So we're studying the activities. Every time the molecule is in an ion state, we call that state an active state, because they're charged, and they gain some sort of ability. And we have only 2 different abilities for very tiny particles like that. They're also objects, by the way. So that's your potential energy and kinetic energy. So every time your ions they're the active state, and we call them the charged state. We can be able to say their concentration because they're active, moving around. Active means moving, having some sort of kinetic energy. So in that solution, so that's what we're studying in our pH, and trying to determine if that solution is acidic or alkaline. So here, your review of your chemistry. So if your elements are in compound, they're always in bond, to each other. So everything that can stick will stick. So here your oxygen and hydrogen can stick, and sometimes they form a bond and we get water. It comes in many different states. It's your liquid state, your gas state, and your solid state is your ice. Ammonia, very common compound. So you have your N and then 3H. Your carbon dioxide, these guys are bad for us. for our biochemical system, your carbon, and then your 2 oxygen, hydrogen peroxide, 2 hydrogen, and 2 oxygen. Okay. So anyway, we're studying them, and they come from elements. So here, this is your elements table, and this is everything we have, okay, that we know here on this earth and beyond, okay, as far as we can go in the space. So anyway, that's what we have, and where the structures, okay, we develop from the combination of some of that. So for human system is your HCO, and we have trace elements like K, Na, Ca, Mg, okay. So these are your sodium, potassium, calcium, magnesium. And then you also have your oxygen. Sometimes you have N right in there, but these are a little bit difficult for our system to survive with them, okay. We are okay with zinc, and it's good for your hair and your nails. And sometimes we take zinc to increase our immunity. And okay with ions a little bit. Nickel a little bit, but not a lot, okay. But sometimes they can be very toxic to us. So anyways, for equipment, it's gonna go mostly iron or copper or aluminum, okay. And most of them are alloys, by the way, because it's cheaper. And we also study them internally, just like we study ourselves internally, because all of us are composed with compounds of these elements. Okay? Therefore, we can study inside out. pH monitoring. Here are your instruments that we use. Chemical condition, call it chemical condition monitoring devices. Okay. So pH monitoring is going to give you, okay, again, internal condition of your equipment. We monitor and then we track the pH, mostly fluids, okay, in the equipment. So fluids are nothing but your lubricants, coolants, and solution, any required solution for a particular type of equipment. So they're and these fluids are the lifeblood of your operating system or equipment. And they can definitely give you warning, okay, advanced warning of your equipment failure. So by studying them internally and their solution or fluids, we can be able to predict their failure. Okay, so therefore we can maintain them. And then we evaluate and compare the chemical concentrations, and then we make informed decisions. Okay, not whatever decision, not the decision because how you feel, okay, but the decision based on the facts. And those decisions are called informed decisions. There are some pictures, and you can see this side is your water and other contaminants. So that's in the solution of fluids in your system, okay? So that's how we use these instruments to monitor our systems, the contaminants in these solutions. And on this side, it's just a variety of portable, again, pH monitoring devices right here. Portable is really good because we can carry it with us, okay? Lighter weight is even better because you have to move around in your plant and facility. So therefore, they're very popular. Okay, the next one is Tropology. Okay, Tropology, some people call it tribology. It's the same thing. It's just an application. And what we're studying right here is the rubbing or friction, okay? Therefore, everything that is rubbing to each other has, okay, a degree of friction. And everything that has friction, you will need the lubrication, okay? Lubrication grease. And if you don't give them enough lubrication, you will definitely get the wear, okay? We don't want that too much. So anyway, it's a relatively new discipline. Okay, it's definitely in a science and technology principle. So what we do here is your dust particles, okay, definitely create friction a lot. Especially you will find a lot of dust particles in the conveyor because we don't do housekeeping every day anyway. The machines are just running, and they can get dusty. They can get dusty, you know, in 1 or 2 days. you can't make the operator, they usually are men and they don't want to do housekeeping alone. Okay, I don't know why, just like that. So women stations are pretty clean, by the way. Okay, so anyway, suspended particles in hydraulic systems, so that's what we're studying in Tropology. So effect on the performance and life of your equipment. So that's what we're monitoring. So what is the effect on our performance of that equipment? What is the effect on the life of the equipment? Because you have to analyze your cost as well, the cost analysis. You don't want to replace the entire equipment. You want to maintain as long as it can go. And also by studying that, it will lead to increased energy consumption. Okay, so if you have issue in these systems, that's all what we do in Tropology to study the friction, lubrication, and wear. So Tropology study, from these studies, what do we get? We get, because the studies show that these particles, even soft material like wood, dust, they can definitely cause corrosive wear. Okay, so that's what we learned from Tropology. So particles, we thought like dust is nothing, but dust can cause over time erosion in your wear. Okay, especially when traveling around bands and under conditions in which materials are sliding against each other. Okay, so 3 general scenarios. This number 1 is a hard metal, maybe sliding against a soft surface, but they still create friction. Therefore, we study Tropology. A soft surface may be sliding against a hard one. Therefore, we get friction. So we study Tropology. Metals with similar properties may be sliding against each other. So therefore, we study Tropology because there are frictions in between these surfaces. Okay. So topological failure are associated with bearings that can be involved in a complete shutdown, okay, of a fully integrated, this is just a system, steel mill, resulting in hundreds of thousands of dollars in lost production in time. So therefore, we don't want topological failure at all in our system because it's going to cost you time and money. Yeah. Lomography. We're going to study the temperature of your system. So among these techniques, we use something called IR, industrial infrared imaging. And it's a very widely used method. Okay. So what do we do here? We detect the surface temperature. We all have temperature on our surface, on our skin, okay, on the table, on the machine, any surface of your system or component, they have temperature. And the temperature definitely, they vary, depends on the type of your material, okay? So usually caused by abnormal or uncharacteristic conditions. So therefore, we have to check the surface temperature. So when we want to check the surface temperature, we use infrared imaging, which is IR. So that's nothing but your heat, okay? Physical or chemical or electrical abnormalities, they are definitely going to produce heat. Heat is nothing but when something is moving. Okay, we can go all the way to atom and molecules level. So every time the molecules move, and we're all composed of some sort of elements, compounds, and molecules. Okay, so therefore our actions, okay, our action is actually just the resultant action of these smaller actions. Okay, by the structure that our system is designed upon. So our structure again is composed of gazillion of atoms and compounds. Okay, so every time these guys move, they produce heat. Okay, so the heat that we have on our system, our body, let's say our machine, and the system and the components that actually come from internal. okay, internal bonds, internal chemical bonds. That's why even though we are in engineering or technology, we still have to go all the way to the foundations of science. Okay, so the foundations of science are what you have to learn as soon as you enter university is your biology 1, 2, chemistry 1, 2, and physics 1, 2. Okay, that's 6 courses is what you need for all STEM major, because without that you have no idea what you're doing. Okay, so anyways, the heat come actually not from the surface, it's actually come from your bonds between very small atoms and molecules. Okay, so what we're feeling outside or detecting outside on the surface, that's a resultant heat. Okay, so that heat that we study is in our system is an indication of a more serious condition inside. Yeah. If I want to give you an example, now we're approaching flu season. So COVID, the same thing. Common cold, the same thing. What do? You study your body temperature. So where does your body temperature come from? Your heat. Where does your heat come from? Your body. Okay. Actually, exactly from where? Okay. The heat come from your molecules. Okay. Of all of your systems. So therefore, you know something is wrong when your temperature change, okay, from your normal body temperature to something else. If you have 110 or something, you gotta think, well, okay, what's going on inside of me? So therefore, by studying the temperature for equipment, we use the infrared IR. We definitely know serious things going on inside, yeah. So require us to take a look at it so that we can have it early and preventive and corrective actions. The temperature always increases. Temperature is not physical. Your heat is an indication. It's called the transfer actually. Transfer of energy is your heat. And what is your energy? Again, potential and kinetic. And what is your kinetic? Then we come into the physical. So your mass of something, okay? And that mass is moving. So you gotta link all of that all together, your physics. So a tiny little mass, it can be atom or molecule or compounds right in the internal system of your machine or you or something, okay? And we're taking the surface temperature. So every time the temperature increases, you know that they are in some sort of motion, okay? Again, motion. So temperature, trying to take the temperature of that motion is trying to find, is my equipment expanding or is it doing? Is it running so long, 8 hours, 9 hours, 10 hours, 12 hours, okay, 36-hour run. So they got hot, okay, and your machine is, even if it looks like so solid from the outside, inside is heating up, okay, meaning like the elements and the compound that compose of your equipment and your system is literally moving, okay, you can see it. But you can see by using IR imaging. Okay, you take IR and you get this, and that's the movement of your internal molecules, okay, in that system. So that's how we study it. So science is incredibly powerful. Miracles are, you don't have to look so far, it's you, okay? You are the miracle. Everything that is existing in our world is miracle. Because you cannot find anywhere in the whole universe, okay, with our intelligence limit. We can't find anything yet. We don't even know how far it goes, by the way, or how it is going. We don't even know the exact shape of our universe, but we know we are on the edge, okay, close to the edge. Every time there is an edge, you have a shape. Every time there is a shape in the universe, you have no idea where exactly that location is. And our intelligence stops right there. So back to our world. So this is how we try to study the material that make us, okay? So here temperature, again, is an indicator of whatever that is happening inside of your system. So therefore we always check the surface temperature. It can be detected, okay? We use infrared imaging, and that's the most powerful right now in our industrial technology field. And we always look at it before your vibration level. Vibration again is moving, okay? Your system is moving internally and externally. Don't forget that. It's always caused by the conditions, okay? And that can reach your detectable point is nothing but your instrument, okay, measuring that temperature. Okay, coming back up from internal to outside, so loose or corroded connectors. Okay, corroded come from your erosion, previous slides, or any other condition that can impede the currents. Currents again is your eye, okay, and you usually study its intensity with your amps and increase your electrical resistance, and it's going to cause loss of energy. Loss of energy it means like loss of ability to either move or stay, okay? There are only two type of energy, basic. Your chemical energy, food energy, everything else is based on that two, potential or kinetic energy, okay? So energy meaning like we come from elements. Elements have nothing but a little structure, usually round, okay? Depends on this nature that we know. They always create a little round thing because of all the forces around it. So anyway, it causes a loss of energy every time you have a resistance, okay, increase. Every time you have it impeding currents, okay. You won't understand if I say electricity and currents, but you can imagine like little molecules and little elements, balls of atoms moving. Every time they move, you're creating ability, okay? Ability mean like these little particles moving come to have some sort of ability to move or stay or be in the bond. So when they are in a bond attaching to each other, you start to get structure. And when the structure built the system like parts and the components and then a big system, then you can see the structure. So now our eye is a structure built from the nature, okay? Nothing but we're CHO and trace elements. And this system can give you a miracle of vision that you can see back to yourself. And you can also see your surrounding and environment. So that's so powerful. Okay, so energy is built again on two foundations, your potential and your kinetic, and then it's going to layer up after another. And now you have too many, okay, properties and energy. You can see, you can hear, you can sense, you can feel, you can cry, shout around, okay, and feel jealous, all kinds of crap, okay, based upon that two little basic fundamental energy. So one is potential and the other one is kinetic. And we love our system because we feel powerful, because we're not the little particle that nobody can ever see, right? You're something. You have a system, and you're talking. You have language. You can feel. You can eat, and you can do all the things that a human can be able to do. And no other species right now, as much as we know, have more power than you. Okay? So therefore, let's go back to our infrared imaging right there. So this technique is dealing with the temperature, surface temperature, and that is based on the fact that all objects, okay, are at temperatures above absolute zero. So here I think I forgot R right here. So all objects are at temperatures above absolute zero. So what is absolute zero temperature? Is when you have absolute zero temperature, you have no motion of any kind. If you take the motion out of the particle, it won't move. So therefore, it won't make any kind of bond. So therefore, the world is going to be as dull as out in the space. Okay, out in the space, what's the difference out in the space and here on our planet? You can compare Mars and us. You can compare Pluto and us. You can compare Saturn and us. You can compare all kinds of rocks, okay, in the universe and us, and you're going to see the difference. And the difference is they're dull. There's nothing cold as hell or hot as hell. Okay, so their structural bonding system is not good. Okay, in these planets. So ours is pretty balanced. That's why we're seeing all the miracles that there is in the world here. So now absolute zero temperature differentiate whether you're going to have a life planet or lifeless planet. You're going to have a life or not. Okay, so here back to all of the objects that we know here on our planet, which is different from everything outside in the space, is that we have temperature, meaning like every structure in this world is moving, has energy, okay? So therefore, they radiate infrared energy. Therefore, we can be able to image that energy by using this lomography, and you can see it. Yeah. Now, infrared imaging also can be used to locate leaking underground piped steam and gas leaks, and other sources of energy and material losses. And it can be used to reveal sources of energy loss from your buildings and industrial facilities. So your subside condominium, whatever in Florida collapse, because that's a failure of the engineering right there. Somebody made a mistake right there, or a huge mistake, because they forget the space. Okay, you have to give allowance of space for the bonds to expand, because the bonds are not lifeless thing, they are living. Okay, not in the living system like us. Okay, everything in the universe is living. In fact, they have a knowledge deeper than our biochemical system. Okay, so their knowledge is forever, infinite. We call that knowledge infinite knowledge, because infinite possibility, or if we call by the stat term probability, okay, so can happen. So what we're trying to say is scientifically, you have infinite potential to create infinite structure out of this existing universe or multiverses, okay, and the material in that. And that is a miracle. That is a miracle. You have no idea of how we have that nature, right? So that's a pretty make you feel very weird sometimes if you study science, because you come to understand up to that point now. Okay, so every scholar, doesn't matter which subject you're studying, we come to know that now about ourselves, what we are. Okay, there is no confusion on, do we have a continuation of life? Yes, there is. Are we continuing? No, we don't. Not in this form. Never in your form. Your form can never be repeated a second time. You can't even clone it, by the way. You can do the image of it. You can do the physical, okay, but you can do both. Or your mind, because it's always depending on the condition, your environmental condition, which is forever changing. So if you want to link to your religious study, Jesus, Buddha, and everybody who's so intelligent born here, they have told you everything about it. Okay, cycles of life, the same thing. You are repeated, but you're not repeated in your form. You're repeated in your genes. Okay, your mother is you. You are your mother. Your children are you, and your grandchildren are you. Okay, so that's how your life is continuing. So yes, we reborn again, 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 again. That's why you feel like, oh, I think I've been here. I think I've done this, because you have already done it. Thousands and thousands and thousands of life in your genes. Okay, and it doesn't change. Just keep going. So in other words, science have already proved majority of the stuff that you are confused, and you don't have to spend your precious time thinking about it or fighting about it, because we already knew all about it. Okay, our energy can never be destroyed. Therefore, what Jesus said is right. You live forever and ever and ever. Infinite. It never ends. Okay, you're going to rise again. Do you rise again as an animal? You rise as a plant? You rise as a machine? You rise as a human? Or you rise as something else? But you will rise again out of the same elements that goes everywhere in the whole universe or multiverses. So back to our maintenance. If you know that much, maintaining a system or maintaining a component is a piece of cake for you, okay? Because there is nothing else more than that we can play here when we are living. So IR requirement is a smart equipment, so you can hold it in your hand, okay? And then you're going to use a laser beam technology. Again, what are we doing? We are detecting the temperature, and we're monitoring our machine. We're not monitoring the surface of that machine. We're monitoring the bonds that compose the structure of that machine from the element level, okay? Very, very small level that you can't see. But this guy can penetrate all the way to the flesh of your machine and give you that temperature or the movement. And temperature is an indicator. If you know the formula of your temperature, review your physics. That's 1/2 m and then v squared. What does it mean? So a little mass, okay, is moving with a velocity v, okay? Your dimension is square, so that's the amount divided by 2 is how they're moving, okay? So that's your physics. Go back to physics to review that. Okay, so here your table 4.5 is giving you your electrical preventive maintenance reference table. So this is what we use for the reference. So you're going to look at your temperature. You're going to see 1 to 10, 10 to 30 degrees Celsius, 30 to 70, above 70. That's pretty critical because it's so hot. Your heat is so extreme, okay? You have to repair immediately overtime. And replace a component, inspect the surrounding. So why do you always have this much of temperature? Because you're operating your system. So every time you're operating, you're moving a long time in that system using it. So therefore, you have to check the temperature all the time. Serious temperature 30 to 70. You're going to repair, okay, 1 to 2 days. Within 1 to 2 days, you're going to replace a component if it is necessary, and you're going to inspect the surrounding components, okay, for probable damage. Intermediate is around 10 to 30. That's kind of cold and kind of warm right there. That's still a little bit hot anyway. So because you're dealing with also the temperature of your boiling temperature is around here and a little bit less. So that's a 2 to 4 weeks. You need repair. You watch your load and change accordingly. Inspect for physical damage. There is a probability of damage in the component, but not in the surrounding components. Minor is 1 to 10 degrees Celsius in a cold zone. You're going to repair in regular maintenance schedule, little probability of physical damage. This is your machine normal temperature, by the way. So our temperature is, so we are flesh, okay? So therefore we're soft structure. So our structure is burnable. So if somebody heat you, you feel, oh, it's hot. Because we are CHO people, organic people, okay? So organic structures are not very good and not strong, but you can think and feel with it. Machine structures are very strong because they are built with like iron or copper or alloy of some sort, okay? So they're very strong, and their temperature, normal temperature, is colder than our body temperature. Ultrasound technique. Okay, so ultrasound techniques are, they're just, we're using frequency. Again, every time you look at the frequency, something is again moving. So here is your ultrasonic frequencies. Now we're coming into the zone of your waves, okay? Short wave. directional signals. So this is how we study outside so far away places like different planets, okay, galaxy, as far as we can send the signal. And that's how we measure the distance and try to understand where are we, okay. Now you already know where you are. On Earth, you are on in United States and Mississippi, Stockville, you know that, okay. You know your neighbor, you know your roommate, your house, your family, and we know the entire planet. We know where that planet is. We locate our galaxy, and we have no idea of where our universe is among other universes. Okay, that's where our signal is lost. So we have to improve our technology to be able to go further and further, further and further. And we start to do the space station to familiarize our body with the space environment. Okay, so the next thing that we're trying to do in technology is we're trying to learn how to harvest the energy out of the space. So we have a lot of hydrogen out there, okay, helium sometimes in some part, some of the planets, and we're studying the gravity with the Mars project. So Mars is the two things going on right there. One is we use something called drones, and you have little miniature drone that's a spin-off space, spin-off technology. So what do we do is you can go there, okay. Human is cost a lot of money, and also nobody want to die right in there in the experiment. So therefore we sent machine to land, okay, to study the gravity on Mars up and down. So they've been successful, okay. Actually, one of the chief, okay, project management in there, actually she's a PhD, is an Asian from Southeast Asia, I believe it's from Burma, but I'm not quite sure because they hide their identity. So anyway, that's a Mars projects, very interesting. It's also linked to industrial technology, so you might also want to go into that direction for your career. Then another project that we have is a probe. So probes are nothing but using extreme viruses and bacteria that we get from Yellowstone, okay, one of them, and also from all over the world, because the space station is an international project. Because we don't have resources right here only in the United States. The resources are they're spread out in the whole world. So you need these material in order for us to be able to survive in the space. We have to do it because we are dead end living on Earth, okay? Especially when the climate changes intensify, it will definitely get rid of the population in a very short time. So therefore, we try to put emphasis on the space projects, okay, more and more in there, more and more. So your children, your our generation, okay, future generation is going to be going toward that direction. And these research are based now, okay. So what do we have to do with? Because we're dead end on the work. We can stick here. You can build. We have already completed everything we can do on the work. What else can you eat more than lobster or crab? Okay, no food is better than eating whatever when you're hungry. That's the best food in the world. So we already know everything about building. What more do you want? You don't need a big mansion because your footprint is only on the space of your foot. That's like less than a feet or 2 feet, okay. So anyways, our emphasis is outside. How are we going to survive right there? How are we going to harvest the energy? And how are we going to make a production of food and whatever we need outside and explore the space? We have to find, to be able to, if we want to continue human species, that's the way to do it. Otherwise, we will extinct just like the dinosaur and all other animals, okay? So anyways, so that's what our research is going. Ultrasonic technique here. The frequency again, shortwave direction signals going back here. So they are beyond the normal hearing range. You can hear it, okay? Ultrasonic coming into our hearing zone, but can be detected by various instruments, and their intensity can be measured, okay? So therefore, we're dealing with the intensity. Again, we're going to apply that to the equipment and systems that we're studying. So all working equipment produces characteristic ultrasound frequencies, or we call that sonic signatures. Okay, so the women know about ultrasound all the time, because every time they've got babies, they have to go to see doctor, and then they can be able to see their baby's image, okay, embryo image, by using the same technology, ultrasound frequencies. So ultrasound frequency, we often detect that, okay, before vibration and also temperature levels. So here in our industrial engineering technology, we study the vibration, we study the temperature, and the next one is your sound, okay? And this one go with the frequency, and you can detect that before vibration and before your surface temperature. So from adverse conditions, it's going to reach your detectable stage. So this is how we put the sound, and then the same thing, create a graph and see the patterns, and that's how we study by using this technique. So here is your ultrasonic detector. It looks like this, nothing, just like a little, device, and it looks like electronic stethoscope. And hearing the sounds are generated by a variety of physical, mechanical, and electrical phenomena. Okay, so you don't have to know everything about it. All you have to know is ultrasound. We have vibration and we have temperature, and we're going to use different devices and instruments to study, okay, our systems and component, your equipment. So here one technique involved using a transducer again. That was the last part one, okay, lecture. So that makes a high frequency ultrasonic waves directed toward an object, or used to flood a shell or a part cavity. Okay, so those are the places that the sound can travel to be able to get the information out of that. The second technique is going to involve the detection of the ultrasound frequency generated by a source. So here we're going to graph it. So this is your ultrasonic versus pressure. So here you can see your y-axis is your ultrasonic in decibels, dB, and then your pressure is in psi. Don't confuse with your inches per second, okay? This is psi, the other one is IPS. Alright, it's vibration stuff. So here, ultrasonic versus pressure drop graph shows how ultrasonic response increases with pressure. So figure 4.41, so here leak rate versus ultrasonic graph shows the non-linear, this is non-linear because it is curved, relationship between your ultrasonic and your leak rate, okay? Ultrasonic frequency generated by damaged pumps, your gears, your gearboxes, your bearings, they can be detected before vibration, again, okay, before, and then can be able to reach at detectable levels and cause any further damage to the equipment. So ultrasound is more powerful than vibration and temperature devices. Okay, so ultrasound here, you just need to know the picture of that. So instrumentation, pinpoint the compressed air leaks, okay, fast before energy is wasted. So we can be able to find the failure like this, okay. So these are your detection devices. And quality affected the adverse. So a user aims here an ultrasonic device along the piping while listening through his headphones for the sound of gas leaks. So that's how we find the leaks, okay, in some systems. Here, this equipment is very big. It's only a part of your equipment. Okay, then experienced user learn, okay, to adjust the sensitivity dial on the instrument, and once a reading is obtained, the operator can consult a comparison flow rate chart to determine an approximate leak rate. Anyway, here we're trying to find the leak, and we're going to use the ultrasound to find the leaks, and we do this, okay? If you go into maintenance line and you get a job, they are going to train you, so you don't have to worry about it here. So you're learning the basic foundations, okay? So this is another handheld condition monitoring device, Okay, here you look at that. In this, we utilize the ultrasound again technology and have a variety of uses in business and in the manufacturing and transportation industry. Okay, we gotta check all these systems. These are all dealing with either manufacturing, transportation. Here, this is your bullet train, Shinkansen. They always have to check because they're going with tremendous speed. Okay, so everything there is going, moving. You have to check. Why do you have to check? Because of your vibration, because of your surface temperature and temperature, internal temperature. Okay, and they can come so loose. Every time your system is loose, it's gonna fail. Okay, and you're carrying people life on them, so therefore you have to pay attention on all of that when you're maintaining the system. That's such a responsibility. Therefore, you cannot be boys anymore or girls anymore. You have to be a man or a woman to take responsibility because your work carry lots and lots of lights. Okay. So here we're gonna go back and study in a flow chart. So here are your equipment, is your system and components. We're studying three major things. One's your vibration, two is your chemical, and the other one's your friction. In chemical, we do pH analysis and SPECT. Okay, get into the solution, do a sample solution, and study inside chemically. Friction, we're going to be doing a surface temperature, Lomography, and then we're going to be checking the leaks and all kinds of stuff with ultrasound. Alright, so that's it for second part of Unit 4.